Okay, hello guys. My name is Rasim. My surname is Zukhba. My patronym is Daurovich. Since no one but Russians use it, I will write it in Russian. Our subject is mathematical analysis, математический анализ, and this first part is an introduction. And this, basically, the first month is not even introduction to mathematical analysis, but I'm like repeating the school program. So a lot of the things that we discuss in the first month should be very familiar for you. Basically, all of it should be known for you. But from experience, I know that different countries have different notations of the same mathematical ideas, and it makes sense to repeat them. For example, we in Russia, in Russian literature, we use decimal comma instead of decimal point. So to write some number, we write 3, 1, 4, and so on. I am not specifically forbidding you from using decimal point, but do try to use our notation because it would be easier to understand you. For example, in some countries they use decimal point and put it in the middle, so they write 3.14. And me as a Russian, I will read this as 3 times 14. This is not what you want to say. Stuff like this. Okay. Our first topic is polynomials, algebraic equations, stuff like that. Definition. A function Qm of x equals is called a polynomial of degree n. Definition. A number a is called a root or a zero of a function if of a function f. If f of a equals 0. definition. An equation q of x equals 0, where q is this polynomial function, is called an algebraic equation of order n. So we are starting with like those kinds of simple definitions, simple ideas. Today we will discuss like solving those equations. I repeat, our job today, well, in the first month-ish, is to make sure we understand each other. So to make sure that yes, this is what we understand. This is how we write, like whatever it is, and so on. I want you to talk to me, ask me questions. So whenever you don't understand anything, maybe it's something as simple as my pronunciation. It could be also a valid question. Ask questions. So any questions so far? Okay. Definition. Such that q of x is not 0, and let t of x and r of x be polynomials such that degree of r of x is less than degree of q of x, and then t of x is called a quotient and r of x is called remainder of division P by Q. So P divided by Q equals T and remainder R. And if R of x equals to 0, then we say that P is divisible by Q. The same as for numbers. Theorem. Let's call it factor. Factor theorem. By French mathematician Bizou. Number A is a root of a polynomial Q of x if and only if linear polynomial, so a polynomial of the first degree x minus a is a divisor of Q of x. Generally speaking, I'm going to prove every theorem that I'm giving you, but I'm going to skip those proofs in this first part in the school mathematics. Those proofs that I do give you, you are expected to learn and to be able to repeat on the exam, okay? And all of the definitions that I give you, you are also expected to learn basically by heart, okay? So Q n of x equals x minus a times some different polynomial of order n minus 1. Definition. A number A is a root of polynomial Q of multiplicity K if there exists a polynomial I will call it Q, maybe with a hat, of order n minus k such that number a is not a root of this polynomial, so qm minus k of a is not 0, and qm of x equals x minus a power k q. So basically this means that in factorization of this polynomial q of x, there is exactly this power of x minus a, exactly power of k. No more, no less. Now, we can discuss different kinds of equations. They are usually discussed, well, with regard to its order, or with the degree of the polynomial. They are linear equations. Ax plus b equals 0, where a is not 0. Those are very easy to solve. They are quadratic equations. Ax squared plus bx plus c equals 0. I think I may have made a mistake. Please check your notes. When I gave you the definition of polynomial, the first one, did I specify that the coefficient Cn is not 0? I think I forgotten it. Yeah, so Cn is not 0. The highest degree of x has a coefficient that is not 0. Please add this. That's why I write this everywhere. So for quadratic equation, we have quadratic formula. That is x first and second we also have Vieta's theorem. It says that the roots of quadratic equation are such that, let me write it carefully, let x1 and x2 be the roots of the quadratic equation. Then and this theorem is, of course, very useful when we could be useful when we are trying to solve the quadratic equation. Example. The quadratic equation x squared minus 5x plus 6 equals 0. Vieta's theorem gives us those conditions. X1 plus x2 equals 5 and x1 times x2 equals 6. And we can easily enough guess those numbers. Those are 2 and 3. Hence, x1 equals 2, x2 equals 3. Okay? So this all should be well known to you. Is this all completely known to you? In Russia, we have all of this as part of our school program, but I'm not sure if it is the same in other countries. In case you are wondering why I'm spending time on school program, I promise that we will get to actual mathematical analysis and it will be much harder, much more complicated. One more useful theorem, I will call it Lemma. Do I have another lemma today? Polynomial. Search that. Its coefficients. C1, Cn, Cn minus 1, and so on. C1, C0 are integer. What are integers? What does it mean, integers? Whole numbers. So 1, 2, 3, 4, but also 0, minus 1, minus 2, and so on. Okay? Whole numbers, yes. Let x0 be an integer root of q of x. Then coefficient C0, that is the coefficient, the last one, the constant, is divisible by x0. Proof. Very easy to prove. Let us calculate q of x0. q of x0 equals cn x0 power n plus and so on plus c1 x0 power 1 plus c0. And since we know that this is a root, we can say that it equals 0. Now, from those terms, all but the last one, we can take a common factor x0. And we can write down that c0 is, and I'm taking, moving this expression to the right side and taking a common factor. x0 times cn x0 power n minus 1 plus and so on plus c1. And we have a minus over here. That's all. This expression in the brackets is also an integer. So we have c0 as a product of two integers, one of which is x0. Since the expression in the brackets since this is an integer, c0 is divisible by x0. Example. We want to factor a polynomial x power 4 minus x power 3 minus x squared minus x minus 2 equals 0. Let me check. Yes. So we have this polynomial. What are how can we factor it? Well, the first part is we want to find some roots of this polynomial, and using this lemma we can start looking for roots among the divisors of this free constant term. So minus 2 is divisible. Minus 2 is divisible by 1 minus 1, 2, and minus 2. Let's check those numbers, put them into our expression, and check if any of those are roots of our expression. Let's calculate p of minus 1. Let's call it p of x. P of minus 1. 1 plus 1 minus 1 plus 1 minus 2. This is 0. Correct? Do you follow, guys? Please ask questions. I understand that this is, it could be difficult to be the only one who doesn't understand something, but this is really this is a really wrong approach. So you don't understand something, but you are afraid to ask a question because you think everybody else understands it and you are the only one who is fool. This is wrong. A lot of other people doesn't understand and also are afraid to ask the same question. Please save your classmates by asking this question that you have, please.
Sir, I think I haven't understood the proof you're looking at.
You didn't understand the proof.
Yes, so I cannot really relate to what you're doing in the class.
Okay, let's go over it again. So, do you understand the proposition? The thing we're trying to prove. Okay, once again. Well, do you see this? You see it, okay. So, suppose we have a polynomial which coefficients are integers. For example, this polynomial is such a polynomial, yeah? All of the coefficients are integers. Plus, minus 1 and minus 2 are all integers. If this polynomial, for example, that one, has an integer root, then this root should be a divisor of C0. You understand? So, skipping a proof for a bit, the application of this lemma is, in our case, we have this polynomial, we have this constant term, and if there is any integer solution for this equation, so integer root, then it should be found among those numbers. Those are all of the divisors of minus 2. Can you see? Okay, so back to the proof. We're trying to just calculate q of x0. This is q of x0. Do you agree? Compare this with the definition of polynomial, the first one that was today. Do you agree that this is how it works? Okay. Next step, I am taking those terms, all but all but the last one. I'm moving them to the right side, and I'm taking a common factor x0. This is what I have. Can you see? Okay. This is it. Look, C0 is an integer, x0 is an integer, and this expression is also an integer. Since each of the coefficients c, k are integers, is an integer, and x0 is an integer, here we have a sum of integers, which is also an integer. Correct?
What about because you say remove this, what about the sign?
The minus sign. Oh, I see. Yes, this is actually a good question. Minus sign, we can move it inside this bracket. Well, let's express it more clearly. Maybe. So C0 divided by x0 is minus this bracket, minus Cn x0 plus so on plus C1. Correct? Yes. So this is minus some integer, which is also an integer. So this quotient is an integer, so C0 is divisible by X0. Okay? Okay, thank you. Thank you for your question. Any more questions? To be clear, this is exactly what I want to happen. I want you to ask me questions. I'm okay with spending some time for this. Once again, later we will move to much harder topics, and if you like skip something, you will like lose the track of the lecture, and you will not be able to continue learning it. So p of -1 equals 0, and also I think 2. Let's calculate p of 2. P of 2 is 16 minus 8 minus 4 minus 2 minus 2. This is also 0, correct? Okay, the other ones are not roots. So those two numbers are roots of my polynomial. Then, using one of the, what was it called? What was it called? It was called Lemma. It was called factor theorem, Bezout's theorem. Then p of x is divisible by x minus this number, which is x plus 1, and also divisible by x minus this number, which is x minus 2, and times some other polynomial. Correct? Do you follow? Okay. So we want to find this other polynomial. What is the degree of this polynomial? Of course, it should be 2, because this polynomial has degree 4, and here we have 1 plus 1. So let's open the brackets. So this polynomial q of x, where is a quadratic polynomial. Okay, let's have a break, 5 minutes break. During the break, you can ask me questions. And those of you who are watching the translation? Okay, who are watching us during the Zoom, via the Zoom, please ask questions using the chat. I have this chat in front of me. Questions that have emerged during the break. Is there a book? Yes, but not exactly the book that we. I'm not following any specific book exactly. So there are some books that will be provided to you. I will send them to you, but I'm not like letter by letter following any of the books. So the problem here is that we kind of stuck with my lectures. On the bright side, all of those lectures are recorded, and you can re-watch them at any time. On YouTube, on some Could you put into the chat the link, reference link?
No.
Not yet.
It's going to be available right now, but a little bit later.
Okay, okay. So, book and notes. Yes, we will also have a list of problems that you should solve. This is basically your homework. There will be a list of problems for this whole semester that you should solve and submit those solutions to your teacher. That would be either me or Vera Markasheva. Me for computer science and Vera for other two schools. And what else? What else were we discussing? Еще раз? Это был задавальник. Could you scroll up, please? There were some messages in the chat that I missed. You can see it, okay. Oh, I will. Book notes, okay. And Lilas asks about the second theorem. I think the second theorem,
You know,
Vieta.
they can ask questions also by chat. They can write question and talk as well.
Lilas, could you please elaborate on your questions? I don't understand it. And if you can't, then please ask it during the seminar. Maybe from me also. By the way, okay, this is light. Okay. Yes, we are solving this problem. So, Q of x is a quadratic polynomial. Let's open the brackets here. So, P of x is x power 4 minus x power 3 minus x squared minus x minus 2 equals x plus 1 times x minus 2, I'm opening the brackets here, is x squared minus x minus 2 times x squared plus x plus c. Now, I'm opening the brackets here, would be a x power 4 b minus a x power 3 c minus 2a x power 2 one more minus b x power 2 I hope I didn't make a mistake here. Please check if I made a mistake. Now, this polynomial on the left equals this polynomial on the right if and only if their corresponding coefficients are equal to each other. This means coefficient in front of x power 4. On the left side we have 1, on the right side we have a. Coefficient in front of power 3 minus 1, b minus a. Вот здесь? Вот здесь? Правильно. Спасибо. X в квадрате minus 1 is c minus 2a minus b x power 1 now we want to find numbers a, b, and c such that those equations hold. Basically, we want to solve this system of equations. This is easy enough because we can say from here we can see that a equals 1. From here we can see that c equals 1. And substituting c into here, for example, we can we can see that b equals 0. Please check if those numbers are really solutions for this system of equations. Is it correct? So, solving this way, we obtain q of x equals x squared plus 1. Answer? Q of x is x plus 1 times x minus 2 times x squared plus 1. Since this equation does not have real roots, we cannot factor it further. Okay? If we could, then we would have x minus x0, x minus x1, x minus x2, where x1 and x2 are roots. But those, we do not have real roots. We could factor it using complex numbers, but we really don't want to go there yet. So, in real numbers, this is the answer. Questions? Questions? Do you follow? Any problems? Меньше камеру возить. Меньше камеру двигать. Или не важно? Не важно. Oh, you don't speak Russian. Okay. I thought it would be easier with the camera?
It's fine for students. Then camera.
Okay. Whatever. Actually, whatever. So let's discuss long division a bit. I'm not for a second think that you don't know how to do long division, but I do for a fact know that in different countries they use different notations. So this is for you to understand the notation. Okay? I'm sure that everybody knows this algorithm, but the way to write it down is different. So let's divide 481 by 13. We look at this first number and try to divide it by 13. We can't. 4 is less than 13. Then we look at the first two numbers, 4 and 8, 48, divided by 13. The answer is 3. Well, there is a remainder, of course, but the whole answer is 3. So 3 times 13 is 39, and we subtract 48 minus 39, and we have 9. Then we move this one over here, we have 91, and we divide 91 by 13, and the answer is 7. Minus 91 equals to 0. Okay, one more example of this division. Let's divide 2021 by, what was it, 17. 2 divided by 17, we can't. 20 divided by 17, 1. 17, subtract. 20 minus 17 is 3, 32. Once again, this is 1. 32 minus 17 is 15. 15. Move 1 over here. 151 by 17 is 8, I think. Yes, 8. The product 8 times 17 is 136, and the remainder is 15. This is remainder. Okay. Any questions, any problems?
Do you know the same for the algebraic division?
Once again?
Like if we divide polynomials.
Yes, yes. This is the next thing I'm going to discuss. Polynomial long division. Okay, and any more questions? Okay, so this is how we write it down. Polynomial division. Let's divide x power 4 plus x 3x 3x squared. Well, basically we can we can try to do like this first part that we did here. Look, here we started by guessing some roots of the polynomial. Here we can also do that, and we can try to guess some roots. For example, let's check if 1 is a root of this polynomial. Let's see. I'm substituting 1 instead of x. 1 plus 3 minus 2 plus 1 minus 3. This is 0, correct? So x equals 1 is a root of this polynomial. So this expression should be divisible by x minus 1. X minus 1. And we do basically the same the same actions. We are making the same actions, taking actions. So x power 4 divided by x minus 1. It should be x power 3. X power 3 times x minus 1. X power 4 minus x power 3. Subtracting. X power 4 cancels. 3x power 3 minus x power 3. This is 4x power 3. 4x power 3 divided by x minus 1, 4x squared. This would be 4x cubed minus 4x squared. Subtracting, minus 2 plus 4 is 2x squared plus x plus 2x. 2x squared minus 2x. We have 3x minus 3. 3x minus 3 plus 3. I think this is how it goes. Do you follow? This is important because I know that not everybody knows it.
Is it necessary to do this in this notation?
Okay, so we have like two objectives here. First of all is understand this notation, use this notation. And the second objective is to learn this new idea for those of you who didn't learn it in school. So, any questions so far?
Can you please explain it?
Okay, so let's see how we divide just numbers. For example, this number. So we have here 2 divided by 17. We can't divide 2 by 17. Then let's move to 20 divided by 17. It's not divisible exactly, but the whole part of the division is 1, correct? So we write down here 1, and then we multiply 1 times 17. We have 17 over here. Let's move over here. X power 4. We are trying to divide it by x minus 1. The answer is x power 3. Once again, this is not exactly the answer, but this is the best approach in the sense that we will like kill this first term, x power 4. Once again, we multiply x power 3 by x minus 1. We have x power 4 minus x power 3. And we are subtracting here. And starting from this point and on, we do not have x power 4 at all. In the same way as starting from this point and on, we do not have 1000 in our numbers. Okay? And then, yeah. Guys from the Zoom are asking if it's necessary to use this specific notation. It is not necessary, but it is advisable in the sense that we will better understand you. And it really is necessary to be able to to achieve this result some way. You can use other method. For example, look, over here we basically did division. We divided this polynomial by that polynomial, but we used a really inefficient method with solving the equations. It does work. It's worse. It's less elegant, I think. It takes more time, but it does work. Actually, theoretically, you can just guess the coefficients over here. Theoretically, it's even less efficient, but maybe you can. During the tests of any kind, tests or exam, you are not confined to the notation that I gave you, but you have to be able to solve it. Sometimes it is basically impossible to solve some problem other than the way we are giving you. So do try to at least understand what I'm talking about. Yes, if you have a different notation, that's okay, but be ready to be able to explain it to a teacher. Yes, but this applies to school topics, those first things. A bit later, when we actually start the mathematical analysis, there will be a lot of things that you are basically enabled to do differently unless you already know the subject. So I will be giving you some definitions, some theorems, and theoretically you can say, no, I don't like this theorem, I don't like this definition, I have my different approach here. It's not it will be not that liberal for you, because if you change one bit of a course, you can really make some mistakes in different parts of the course, which are not easy to spot for a student, very difficult to spot. But I will accept, for example, the approach that is in the books that I will give you. So if you want, instead of the way I explain it on the lectures, if you want to have the explanation the way it is explained in the book, it's okay. But you have to follow the book throughout the course, which is a lot of work. Maybe you will prefer this, but maybe not. I don't know. Okay, I think I answered this. What's your name?
Martha.
Once again, Marta?
Yes.
Marta. Marta.
Oh, Martha.
Once again?
Martha.
Marta.
Martha.
Like this?
Yes.
Okay, Marta. So, Marta, yeah, do you understand it now, or should I explain further?
I understand.
Okay, I don't know. Yes. Moving on. How much time do you have? not that much time. Okay. Okay, we still have to discuss the inequalities. So, definition. A quotient of two polynomials is called a rational function. So a rational function is one polynomial divided by another polynomial. This expression, this function. We will discuss the definition of continuity a bit later, much later actually. But let's use this idea of continuity. The proper theorems will be proved at the proper time. Lemma. Let x1 and x2 be consecutive roots of denominator q fix of a rational R of x. So let's look at two consecutive roots of the denominator. Then the function R of x is continuous on an interval from x1 to x2. I should probably write down what is an interval. Definition. A set okay, this is maybe a notation that you might not have seen before. So I'm defining a set of numbers. I'm writing it like this. All numbers x, let's write it from the set of real numbers. This will be representing a set of real numbers, which we will define later, such that the next condition is true. a less than x less than b. This set of numbers is called an interval a b. So this is just a way to denote this set of numbers. Greater than a but less than b. Definition: a set such that a less or equal than x less or equal than b is called a closed interval. A, B. So this is an open interval or just an interval, and this is a closed interval. And this lemma says that my rational function is continuous on this open interval in between two consecutive roots of the denominator. Lemma. Let function f of x be such that not equal 0. Let me write it a bit differently. No. Let for any x from a to b f of x not 0 and f of x is continuous on an interval AB. So function is continuous but does not attain 0 on this interval. Then this function keeps its sign, so it's either stays positive or stays negative on this interval. That is either x is b f of x is positive or x from once again, maybe something new that you maybe not seen before. This symbol means for any or for all. This is to be read for any x from this set. So for any x from a to b, it follows that f of x is greater than 0. Basically, I could have written this over here. For any, this A upside down sign.
What does mean this arrow?
This means, this arrow, I understand. This arrow is like a punctuation mark that expresses that so this is a condition, and this is what follows from this condition. So for any x, it follows that this happens. Basically, you can read it as it follows. Okay, so looking at those two lemmas, we can use this method of solving equations, inequalities. So let's solve an inequality R of x, which is P of x divided by Q of x, say greater than 0. We want to solve this inequality. Let's find all roots of numerator and all roots of denominator. Let's put them on a number line. So x1, x2, x3, and so on, x4, and so on. Those are all roots of numerator and all roots of the denominator. Let's take a look at one interval between any of those two roots, of two consecutive roots. For basically from xk to xk plus 1. Two consecutive roots, either of denominator or numerator, that doesn't matter. We know from this lemma, I think this was lemma 2. Let's call it lemma 2, and this lemma 3, and the first one was lemma 1. From this lemma, we know that the function is continuous on this interval. And since on this interval we do not have any roots of numerator, the function is not 0. This is continuous at not 0 function on this interval. Then on this whole interval, the function keeps its sign. So it's either positive or negative on this whole interval. And to solve this inequality, we can, for example, check any number from each of the intervals and see what is the sign. For example, maybe on this interval, at some point, we can see that the function is positive, then this function is positive on this whole interval. And so on for each of the intervals. Okay, our time is up. Any questions?